Welcome to everyone. Today, as I have already done a numerical for you in the previous video, so today we are just going to look at a new numerical problem here. So according to this question, some of the parameters or some of the dimensions which are given to us, like length of building, that is 48 meter, height of building is 33 meter, width of building is 40 meter, location is in Calcutta, so it lies in the category second. And now this is the basic parameter which I am just going to discuss today. So here you can see that theta is 10 degree. Okay, so in the previous numerical, I have taken theta is less than 3 degree. If you remember that in the last numerical, I have taken theta as 3 less than 3 degree. So now the next parameter which we are just going to discuss today is the height of hill. Okay, that is given 900 meter. The location from the crest is 200 meter, and the design life of building is 50 years. And the total height of the height of each story is 3 meter. Okay, so now as from these details we can just draw uh, a plan and an elevation. Okay, elevation of the building. So here you can see that the bay width, as I have already discussed in the previous video, that what is bay spacing or bay width, okay, that is given to us is 4 meter. So now here you can see that with the specifications and with the dimension which are given to us in the question, here you can see that this is the plan which I have already made for you. And from here you can see that the length of building is 48 meter. Okay, and the width is 40 meter. Okay, and now I'm just going to I have drawn elevation of the building. The total height of the building is 33 meters. Okay, from here you can see that this is the total height of building, and that is 33 meter. So one more thing I would like to just tell you here, that the height of each story is 3 meter. So number of stories would be 11. From here now we can calculate the number of stories, like that the total height is 33 meters. Okay, 33 meters is the total height, and when divided by the height of each story, it is going to give us 11. Okay, so this is the total number of stories. So now let's just move further toward our question. Okay, so as I told you that the step one is design wind speed. Okay, and the formula for design wind speed is given to us, that is Vz is equal to V1 K1 K2 K3. Okay, so VB, as I told you, that VB is the basic wind speed in the given region. Okay, so the region or city, we can say it is in Calcutta. So basic wind speed in Calcutta is 50 meter per second. And now the value of K1 is calculated from this table which you can see on your screen right now. Okay, so as we know that design life of a structure is 50 years. So according to question, it is clearly mentioned that design life of structure is 50 years. So now as we can see that there is a the value of K2 that we can find from this table. Okay, so here you can see that the value of K2 is totally dependent on the category. Okay, so terrain category. So here you can see that in the question the terrain category is 2. Okay, the terrain category is 2. So for different level of height, example, like for 10 meter, the for the terrain category of 2, the value of K2 is 1. Okay, for a height of 15 meter it is 1.05, for 20 meter it is 1.07, for 30 meter it is 1.12. Okay, so now as we can see that the total height of our building is 33 meter. So now the 33 meters that it is not given here. Okay, so the value of 33 meter, for the height of 33 meter, the value of K2 is not given. So what we're gonna do here is that we're gonna interpolate two values, that the first one is 30, the second one is 50, and between that we already know that our value, that is 33, that is the height of our building. The value 33 will definitely lie between 30 and 50, and for 30 and 50, like for 30 it is 1.12, okay, the value of K2, and for 50 meter it is 1.17. So we can use the method of interpolation, okay, and easily find the value of 33. As you can see here, I have find the value of K2. Okay, so from figure you can see that the value of K2 from table 2, I have taken different values from the table. For 10 meter it is different, for 15 meter, for 20 meter and 30 meter they are totally different. The value of K2 is totally different. So now as I told you that here for the height of 33 meter it is not given in the table, so we need to interpolate here. Okay, so for interpolation, this is the basic formula for linear interpolation. Here you can see. So now here we will consider this 30 meter is x1. Here we will consider this 30 meter as x1, this 33 is x, 50 meter as x2. So the same things which we are going to do here is that for 1.10 it will be considered y1 value, for the unknown value we will consider it as y, and for the 1.17 value it will be considered as y2. So now we can just completely use this formula by putting all the value of these, okay, which we are known from this table. So now we can put those values in this formula. So after putting those value in this formula, we can find the value of K2 at the height of 33 meter, that is 1.11. So now as you can see that we need to find the value of K3, and the main problem in finding the value of K3 is that theta is given here is 10 degree. Okay, so in the previous question it was given less than 3 degree, so we just for theta value less than 3 degree, we generally consider the value of K3 is equal to 1. But now here you can see that now the value of theta is greater than 3 degree. So what we gonna do now? Okay, so for solving this problem, generally here you can see that uh, we have a formula for the calculation of K3, that is we had a formula for the calculation of K3 value, that is 1 plus CS. Okay, so now I'm just going to tell you that how we can find the value of C, okay, and the value of S. So now what I'm going to do here is that there are two conditions which are generally arising here. And the first one is if the slope, the value of slope, that is the angle, okay, if it is lying between 3 degree and 17 degree. So here you can see that if the value of theta is greater than 3 degree but it is less than equal to 17 degree, so we can use this formula, that is C is equal to 1.2 multiplied by Z upon LE. Okay, so we can directly use this formula. But if the value of theta, that is 10 degree in this question. So if the value of theta is greater than 17 degree, so the value of c would be directly 0.36. Okay, so now as I told you that if the value of theta is greater than 3 degree and it lies in the 70, it lies below 17 degree. So here you can see that according to our question, our angle, that is theta, it is given as 10 degree. So it definitely lie between 3 degree and 17 degree. Okay, so as you can see that above I have already told you that if the value of theta is lying between 3 degree and 17 degree, so we are going to use this criteria for the calculation of c. So now in order to find the value of c, okay, here you can see that this is the formula, K3 is equal to 1 plus cs. So now in this in this formula there are two unknowns, where you can see this, the first unknown is c and the second one is s. Okay, so c is equal to 1.2 into z upon le. So this is the basic formula to find the value of c. So now here we can see that in this type of question where theta is greater than 3 degree, okay, uh, so the some values are already given in the question, like now from this diagram you can easily see that uh, as according to our question, first we will draw a hill. Okay, because the height of hill is given to us, that is 900 meter. Okay, we are denoting it by z, capital Z. So the value of capital Z, that is the height of the hill, is given to us, that is 900 meter. So now the value of um, the distance of hill from the crest is given, that is 200 meter. Okay, so now here you can see that the angle it is given to us, that is 10 degree. It is already given in the question. Okay, so now what we are going to do here is we are going to, okay, let me just draw this again for you. According to the values given in the question, I have prepared a diagram. Okay, so here you can see that I have made a hill. Okay, I have made a hill like this. Okay, and this is the surface. Okay, so let me just show you the question one more time. Okay, so here you can see that the theta is given to us, that is 10 degree. Okay, the height of hill is 900 meter. Okay, that we are denoting it in this diagram by capital Z. Okay, so now location from crest. Okay, so crest, I would like to just tell you that crest is known as the highest point of a hill. Okay, the highest peak, or we can say that the highest point of the hill. So it is 200 meter. So now, as per the values given in the question, I have told you that we are representing the value of height of the hill by capital Z. Okay, that is given to us 900 meter. Okay, and distance the distance of the crest from the hill, that is 200 meter, and we are denoting it by x. Okay, so and the angle given to us, that is 10 degree. Okay, so here I am representing the value is the flow of wind. The flow of wind is from the upper side. Okay, from here the wind is blowing. Okay, so I'm naming it as the upper side, and this is the downside. Okay, and this value I'm denoting it by capital L. Okay, so I'm representing this value or this dimension by capital L, that is unknown to us. Okay, that is not given in the question. So we generally take it as a width of the hill, that is from the distance from the crest to the outer side or outermost layer of the hill. Okay, now from the mathematical formula, you must know that from the trigonometry concept. Okay, tan theta is equal to perpendicular upon base. So now here you can see that for this a particular figure, we can consider this as a perpendicular. Okay, because theta is given to us, and this value. Okay, so this thing we are considering as perpendicular. Okay, and this value we are considering as a base. So now we considering it basically a triangular figure. Okay, so this is the theta. So from here we are considering it as a tan theta, which is perpendicular, and this is the base. So in the formula it is can be written as perpendicular by base. So from here I have taken the values like for the perpendicular dimension, that is Z, and in the base that is denoted by L. Okay, so I'm putting the value that theta is 10 degree. So as theta is 10 degree, so I'm taking here 10 degree. Okay, the value of n I'm taking, this is the value of Z. Okay, so this is 900 meter, and the value of L is unknown to us. So the L dimension is left as it is. So now from here, so this is the value of L, that is 5104.153 meter from the crest. Okay, so if we look at the formula, okay, the formula of C is equal to 1.2 Z by LE. Okay, so we would be requiring LE, that is the effective length. Okay, that is the effective length, but now we are only having the value of L. Okay, that is not the effective length. So as per the IS code, appendix C1 says if theta is greater than 3 degree and less than 17 degree, so the value of L is equal to effective length, that is LE. So here L will be equal to LE, and LE value would be considered as the value of L, that is 5104.153. So now the value of C we can generally calculate by putting all these value from the formula. So it would be 1.2 Z. Okay, the formula was C 1.2 Z by LE. Okay, so here you can see that I have taken the value of Z is equal to 900 and LE is 5104.13. So now the value of C would be 0.211. So the value of C we have already calculated, that is 0.211. Okay, so the remaining value that we have to find is S. Okay, so now the unknown value is S. So to find S, so we know that the value of S depend on the ratio of X by LE and the ratio of H by LE. So from this figure you can see that the value of X is 200 meter. Okay, and the value of LE that is 5104.135 from this condition. Okay, so now putting all these value in this formula, okay, so we would be able to find the ratio of X by LE. So now moving toward our second condition, that is the value of H by LE. So now let me show you, okay, the figure which we have already made here. So from this figure, as you know that we know a property, okay, the bigger height divided by the bigger dimension, yeah, or we can say the bigger width. So this is the L which we generally consider as LE. Okay, and the bigger height, okay, that is Z, that is 900 meter. Now we will consider the bigger dimension, the ratio of the bigger dimension, okay, and the smaller dimension. We will equate them like here you can see the bigger dimension, that is Z, okay, for the vertical dimension, and the bigger dimension, that is L, for the horizontal direction. But now we are going to equate it with the smaller dimension, so we are considering this value, okay, that is H, that is H, we are considering it, and the smaller value that will be uh, L, this is the dimension. So this is the smaller dimension we are considering, okay, that would be total length, okay, total length minus 200. Okay, so now smaller dimension, that is H, okay, and the ratio of both values will be H by L minus 200. So now uh, we will just put the values of these ratios, that is H by LE minus 200 is equal to 900 by LE. And after solving, because we know that the value of L is equal to the value of LE, okay, so it is 5104.153. so putting all these value in this formula, we would be able to find the value of H, that is 864.73 meters. So after that we will calculate the ratio of H by LE that we need to find according to the conditions, okay, that is given to us for finding S. The first condition is X by LE, ratio of X by LE, and the second condition is H by LE. So now here you can see put the value of H in this formula, and from there we would be able to find the ratio of H by LE, that is 0.169. So now to calculate the value of S, we will go through the figure 17 in the code. Okay, this is the figure number 17. Okay, from here we can see that it is divided, the hill is splitted into two parts. Okay, the first one is upwind, okay, from where the wind is blowing, and the second one is downwind. Okay, so here you can see that the value of h by l, okay, the ratio of h by le is 0.169. Okay, and the ratio of x by le is equal to 0.039. So we with the help of this graph, here you can see that at the vertical side, okay, here it is representing the ratio of h by le, and in the horizontal side you can see here it is representing x by le ratio. So from here that we have to take the right one graph, because we are calculating all the value in positive. Okay, so here you can see that x by le ratio, that is the downward side, the x by le ratio, that is 0.039, it will lie nearly here. Okay, and the ratio of h by le, that is 0.169, will also lie somewhere here. Okay, so here we would be finding this, the value of that is s. Now, as we know, the formula was K3 is equal to 1 plus CS, and the value of CS we have calculated, that is 0.211, and the value of S that we have just calculated, that is 0.7. So after solving this, we would be able to find the value of K3, that is 1.147. So we are taking a nearby value, that is 1.15. So the final value of K3 is equal to 1.15. And as I have already told you that how to solve the numerical, okay, so by following the previous video steps you can easily solve this question ahead. I hope you found this video helpful and it will help you in your examination. So thank you.